It's the first lesson of the new semester, and so it's Introduction to Polynomials. That is our new section that we're going to be going over the unit. So we need to go over some terms first and just kind of explaining what things are. So this one will not be so much math heavy as more definition heavy. So terms are the parts of an expression that are separated by addition signs. So if we were to rewrite 5x plus 3 minus 7y, we would write it as 5x plus 3 plus negative 7y. Get this so you can see it. So 5x plus 3 plus negative 7y. So that means our terms are 5x and negative 7y, and I'm trying a new font or new pencil. I got pencil lead 50%, so hopefully it works and you can see it well. It writes a little thinner. Make it darker. There we go. Okay, so a coefficient is a number that multiplies a variable. So a coefficient is a number that multiplies a variable. And so when we have the same three terms, 5x plus 3 and negative 7y, the only ones that are actually coefficients are 5 and negative 7. The 3 does not have a variable, so it's not a coefficient. And then just as an example, 5x, a polynomial is an expression of two or more algebraic terms. So 5x to the fifth plus 3xy minus 7y is just an example of a polynomial. So now I'm going to give you this is one part that you want to keep right here that I'm boxing up. Terms, so a constant is a term with no variable, so like the number 2. Linear means it's a variable of degree 1, like 3x, so it's a line. And we did lines at the beginning of the last semester. Quadratic, degree 2, 2x squared. That's a quadratic. It is a function that looks like, well, I'm drawing a blank right now, but we went over quadratics a lot last semester. Cubics, we have not gone over those yet. Those are degree 3. Negative 3x to the third. Quartic, degree 4, 2x to the fourth. Quintic, degree 5. So we're not going to really do much with quartics and quintics other than being able to label those. When we're writing in standard form, we always write polynomials in order from highest degree to lowest degree. So for 2x to the third minus 8 plus 8x minus 9x squared, the highest degree is the 2x cubed. The next highest would be the negative 9x squared. Then we go to 8x, so plus 8x minus 8. So hopefully you can read that okay. All right, and then another section that you need to know. So we've gone over linear, quadratic, cubic, quartic, quintic, number of terms. So a monomial is one term, binomial 2, trinomial 3. If you have more than 3 terms, I just want you to call it 4 terms, 5 terms, 6 terms, whatever it is. So as we're looking at 1 through 5 here, we need to label these by the number of terms, by degree and number of terms. So if we look at 4x squared minus 2x plus 3, we want to look at the highest degree. So x squared is a quadratic. So I'm just going to put quad, and there's 3 terms, so it's a quadratic trinomial. 2x to the fourth plus 5x squared, that's degree 4. Degree 4 is a quartic. So quartic. And there's only 2 terms, so that's binomial. Binomial. The next one we look and see, we have degree 5, 3x to the 5th. Fifth degree is quintic. So I'm sure you've heard linear, quadratic, and cubic before, but quartic and quintic are probably new to you. And this is also a trinomial because it's 3 terms. Last two, we have 8x plus 3. So the 8x is the highest degree. That is linear. A linear equation or graph or function, and it's binomial because there's only 2 terms. And then the last one, 6x cubed. X cubed is cubic. And one term is just a monomial. Alright, so we can see we have a quadratic, we had a quartic, a quintic, a linear, and a cubic. We had all 5 different ones. So now we have to write in standard form, then classify by degree. So remember, standard form, that means decreasing order of degree. So for number 6, the x to the 3rd is the highest degree. The next is the negative 5x squared, followed by x and minus 7. So the 3rd degree would be a cubic. Kind of like this writing in pencil, it looks good. And then there's 4 terms, so I would just say 4 terms. That's all I can do. Number 7. This one is pretty simple. Just rewrite it. So I have 6x to the 4th minus 1. 4th degree is quartic. 2 terms is a binomial. I guess I'll try to spell it out this time. The last one we have to do a little more work. So we have x and we have to distribute. X times 2x minus 3 plus x squared. So we need to x times 2x. It's going to be 2x squared. X times negative 3 is negative 3x. X times x squared is x cubed. And then I need to rewrite it. So x cubed goes first, then the x squared, and then the regular x. So x cubed we know is cubic. If I can write it in here. Let's try this again. Cubic, and there's 3 terms, so it's a trinomial. Alright, so let's take a look at all that right there. Freeze it if you need to. Okay, so now we're going to flip over the page. If you give me a second. We'll get to the second page. And okay. So now we are what do the graphs of polynomial functions look like? So in this case we are talking about generalizing, and we're looking at starting behavior and ending behavior, and a lot of times you'll see I'll just ask for what are the end behaviors of the graph, and so that's what it means, starting behavior and ending behavior. So a quadratic with a positive leading coefficient is going to open up. It's a parabola, that's the word I was looking for earlier. It's a parabola that opens up. End behavior, so I'm looking at the arrows. And we always go from left to right. So the start is on the left-hand side. And so you can see it says, it is said f of x goes to infinity. That means f of x goes up as x goes to negative infinity, to the left. What I'm really looking for from you is knowing it goes up. So starting behavior is up, ending behavior. So it is said f of x goes up to infinity as x goes to positive infinity, also up. So I want you to look at the algebraic reasoning of f of x goes to infinity as x goes to infinity and all those, but what we really need to know is when the quadratic is positive, the starting behavior is up and the ending behavior is up. When a quadratic is negative, the starting behavior is down and the ending behavior is down. So odd degree and positive. So that's, you have your x cubes, x to the 5th, x to the 7th, and we're only looking at the highest degree here. So starting behavior when it's positive is down, and it ends up. So when you have an odd degree, you always have opposite starting and ending behaviors. So if it's plus, you start down and end up. If it's a negative coefficient, you start up and end down. So anytime you have an odd degree, it's going to have both an up and down behavior. Now when we get to even degree and positive, so if you think about it, even and negative, even and positive, they should look and act like a quadratic, because if you remember, quadratic is even. X to the 4th is even, x to the 6th. The only difference, the differences between x squared, x to the 4th, x to the 6th is what happens in this part here, the blue part that I just circled. That's where the higher degree, the more up and downs you'll have in the middle. But the end behaviors will still be the same. When it's positive, it's up and up. When it's negative, it's down and down. All right, I hope that helps, and make sure you check back often for more lessons.